Hello. Yeah. I think now it should be clear. Okay. So we are live. We are back again with some more coding questions to solve. And I was on a break. I went home. I had a great experience at my home. So I did a lot of things. I enjoyed a lot. And now it's time for us to enjoy our coding. So so today we'll be doing the same thing. We'll be solving uh, code forces questions as best as possible. So we started from, I suppose, 1100, and I know 1200. Yeah. So we started with 1200. Let me mute, reduce audio. So we started with 1200. Then we went to 1300. So we solved 8 questions from 1200, and after that I saw that many questions were very much similar, and it was the rating was going down. So it should be easier for me to solve rest of the question. Maybe if not, we'll try to go back again and we'll solve again. And then we came down to 1300 rating question. So now we are solving 1300 rated question. So mm, I think we tried these directly, but we didn't solve it. Maybe I was getting something wrong related to this. No problem. We'll go down and we'll come back again if not, because I forgot what was the question. So again, the l- process will be same. We'll be doing 50 minutes of coding and then 10 minutes of break, and then we'll be back again with 50 minutes of coding and 10 minutes of break. So this way we'll be solving the question. So let's just directly jump to the questions, and let's do it. So let me start my timer, and after 50 minutes I will stop, and then so let's go. So the first question, let's pick this strong vertices. I don't know what question is this. Okay, what is this? I'm not logged in. Is it so? Mm-hmm. Okay, but why it is? Why it is looking something like this? Hey, I don't know why it is like this. What? Uh, why? Code forces. The UI is so bad now. Shouldn't be. I don't know. Oh, okay. Can I go back to the old UI? Uh, can't even remove this. It's fine. Close it. Close. I don't want this to be there. From where should I close it? Take. Fine. Leave it. I'll do it like this only. Okay. So we have been given two arrays, that is A and B. So we have two arrays A and B. Fine. Let's see what both of length n. Both of A and B is of length n. Length is same for both. Elements of both array indexed from 1 to n. Okay, fine. You are constructing a directed graph. Okay, it's a directed graph, so it will have a direction where edge from u to v, which is u is not equal to exist if a of u minus a of v is greater than equals to b of u minus b of v. So if there is a edge u to v exist, if this condition is followed, a vertex v is called strong if there exists a path from v to all other vertices. Okay, means I need to know whether I am able to reach all the other vertices from a single vertex. Then that means that vertex is strong. Okay, fine. A path in a directed graph is a chain of several vertices, edges connected such that moving from vertex u along the direction of the edges, the vertex v can be reached. So it's saying, for example, if my A is 3, 1, 2, 4, and my is 4, 3, 2, 1. So the graph will look like this. So first I need to handle this case. It's saying u and v. That means hopefully we are talking about the indices. Okay. So in this case we are talking about the indices, that is maybe 1, 2, 3 and 4. 1, 2, 3 and 4. So we are saying we'll go one by one for each and check whether there is an edge or not. Okay, so there should be an edge from 1 to 2. So 1 to 3, there should be an edge from 1 to 3. Even it's not possible that it should be in a in a direct path. It can be via, correct. So via can also be possible. It's fine. Just a sec. So there should be an edge between U to V. Now a of U minus A of V should be greater than B of U minus B of V. So can I uh, do some changes over here? These operation, this finding this will take O of n square. So let's try do something which is possible. So A of U minus B of U should be greater than equal to, if I shift this one, so A of V minus B of V, correct. So A of U minus B of U, A of V minus B of V. Now so A of U minus B of U, that means 3 minus 4, it's something like that. So A of I minus B of I, if I create a array of something like this, so maybe I can keep a map where I can store, but how do I get to know? It's asking for a path from V to every other indices. It's not asking for a direct path. So okay, so A of U minus B of U is going to give me a -1. So I added -1 with an index, maybe here val and with an index idx index 1. Now 1 minus 3, which is nothing but -2. If I keep it in sorted way, this should go. So let's -1 with 1, -2 will come over here with an index of 2. 2 to 0, 0 will come over here with an index of 3. And 4 minus 1, that is 3 with an index of 4. So I can say that 4 will have an edge to all the 3. 3 will have an edge to 1 and 2. 1 will have an edge to 2. And 2 will have an edge to none. Right. Okay. What is the possibility that there will be multiple answer? So from here I can say that 4 is covering all the other 3. right? So if some else value will come over here, I can say that there if saying so maybe index 5 can also come over here, index 6 can also come over here. So 4 5 6 all will be strong. Let's see some example. It's saying the second last example. Let's take the second last example. So the second last example is 0 2 1 and 1 3 2. So I'm saying I'm creating a map 0 minus 1, which is nothing but negative 1 with an index of 1. 2 minus 3 will also be a negative 1 with an index of 2. 1 minus 2 is also a negative 1 with an index of 3. So all these values are possible, right? Okay, the second test case. Let's see the second test case. This should be a better. So question is 1 2 4 1 2. Okay. 5 2 3 3 1. So our map will have 1 minus 5, that is nothing but negative 4. Negative 4 with an index of 1. 2 minus 2 is a 0 with an index of 2. 4 minus 3, which is 1 with an index of 3. Like index is 1 2 3 4 5. 4 minus 3 is done. 1 minus 3 is negative 2, which will be adjusted over here. Negative 2 with a value of, with an index of 4. 2 minus 1 is 1 with an index of 5. So 3 and 5 is the answer. Okay, so the last one I'll have to pick because this will have all the edges connected to it based on that condition. I think this is not difficult. We got the intuition, we got to know how we can approach to this question. Maybe let me open my Sublime and then we can code it out. So what is the question? D, strong vertices. Why? face problems with it. It's Sublime. I don't know why. It is saying. If I don't add to this, now it is running. Okay, so what are the inputs that we need to take? Let me split. Okay, screen in half. Now it's fine. So the inputs are 5, 4. Total inputs 5. Array size is 4. So total times is 5. That will take. I need to take a length, and then I need to array vector int a of length size and b of length size. Okay, now I need to call my solve. It will return what? It will return a vector which needs to be printed. So it will return a result in the form, integer result, which is nothing but passing a and b with len. So let's take so we have these three parameters, a, b and len. What I want to do is I'll create ordered map. So this will be a map of integer comma integer, because the difference will also always be in integer format. The values are huge. Should be long. Let's take long. Yeah, I have ll. So if diff a of I minus b of I dot push back current index. So this diff will have vector of ll instead of normal ll. It is equals to So I'll be returning previous of diff.end, which will be stored over here. If uh, if it is not equals to it dot begin, if it is equals to it dot begin, return it second else previous of it goes. That's the problem with previous of it. Second, will that this so I need size also, right? I need to print result dot size, then next line, then print everything. It's a one based index. 2, 3 and 5. For 1 it's 2, for 3 it's 1, 2, 3, for 2 it's 2, 3. Seems fine. Let's try. What is the file name? Okay. Great. So the strong vertices was not that difficult, I would say, but it was a good question because if you don't do this manipulation, I would say that you won't be able to uh, you won't be able to understand it properly, because a of u minus a of v is greater than, should be greater than, equal to b of u minus b of v. If this is the case and you don't do any operation or any manipulation on this, it will be difficult for us to understand like how to approach to this question. So when we converted this equation to this equation, we got some intuition like how to do, and by one or two dry run on the example we got to know that okay, this will be our approach and this is how we should be doing it. So it's great that we were able to figure out the approach, so it's nice. This was a good question, strong vertices. Yeah, if you want you can also try this question. I'll paste it in the chat. Let's go to the next question and let's see what the next question holds. I don't want this to be in half of the screen. Why it is coming in the half of the screen? I want it to be complete full screen, but I don't know why it is not coming. Is it something light version of this code forces? But I don't have any URL named light. Okay, then let's look at this question and see what this question holds, and then we'll figure out. So is this, let's call the Manhattan value of a permutation P the value of expression. What is this Christian symbol? Jesus. Sorry. So let's call the Manhattan value of a permutation P the value of expression. So the expression is something P1 minus 1 mod P2 minus 2 mod dot 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 plus Pn minus n. So from this what I can conclude is, I can conclude something, that this mod value will always give me something positive. So the answer of this total after summing up will always be greater than equals to 0. Will always. That we know. Till now we know this. Okay, it's fine. Next question. Next statement says you are given integers n and k. So we are given integers n and k. Find a permutation p of length n. I need to find a permutation p of length n such that its Manhattan value is equal to k. Okay, so it should be its Manhattan value should be equals to k. Okay, I'm getting something. Okay, let's see with an example. Let's understand this much more clearly and see. A permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. Two, three, one, five, four. Consisting of n distinct integers from 1 to n in arbitrary order. For example, is a permutation, but 1 to 2 is not a permutation. 2 appears twice in the array. 3, 4 is also not a permutation. N is equal to 3, but there is 4 in the array. Okay. So it is saying something. This n, can we convert this to something? I know this, that the answer will always be something positive, right? You are given an integers n. Let's see what. So we have two integers n and k, which is nothing but 3 and 4. So n and k is nothing 3 and 4. So I need to have the permutation ranging between 1 should be greater than 1 and p should be lesser than equals to 3. That means p should be greater than equals to 1 and lesser than equals to 3. And should be unique. Means all the values ranging from 1 to 3. And I need to make 4. So the ordering that he decided is 3, 1, 2. That we can make 4. How we can make 4? If I subtract 1 from this, it will be 2. If I subtract 2 from this, it will be negative 1, which is nothing but 1. And 3 with this is going to give me 1, and which is nothing but 4. So what we got is 3 minus 1 plus 1 minus 2 plus 2 minus 3, which is giving me 4. Can we do something like that? 3, 4, 5, 1, 6 minus 6. No. 6 minus 6 will always give me 0, which is nothing. Which is not possible. So I can't do something like separation, because I know that what if we start from back and we progress sequentially? What will happen? If I subtract 3 and then 2 and then 1. If I go something like this, what this will give me, it'll, uh, it'll always give me a value which is greater than, which will be maximum if I do this. And subtracting, like 3 minus 1 will give me 2. 2 minus 2 will give me 0. 2 minus 2 will give me 0, and 1 2 3 3. So 1 minus 3 will give me nothing but 2. So it's again 4, right? In this way also 4. We cannot make more than 4. So there is something that I know, if my sequence is reversed, so like 5 4 3 2 1, and I subtract it with 1 2 3 4 5, eventually I'll come up with a value which is the maximum, a value which is maximum. I cannot increase more than that, right? So I'll come up with a value which is maximum. Now I need now if my k is more than that, then it's not at all possible for me to handle that. If my value is lesser than that, might be possible that we can somehow do it. Now we need to figure out how. So suppose n is 5 and my k is 2. Can we make a 2? Can we make a 2 out of this? Let's see. Let's erase few things, and let's make it a little smaller. Let's go with 3, and value which I want is 2. Now I have to have something. I have 1 2 3. If I go it with this sequence, it won't be possible for me to make up a k value which is 2. If I go with 2 1 and 3, what will happen? So let's make it more smaller. Let's start with 2 digits. So n is 2, and then we can jump to 3, and k is suppose 1. So the values that n can attain is 1 and 2, right? Now my k is 1, which I want. So if I do it 2 1, if I change my n to 2 1, so in this case I'll get a value 0. In this case I'll get a value 1 plus if I do it 1 1 over here. Uh, 1, so we will get 2. It's not possible for me to attain 1 over here. We can only get 2. Fine. Now we have 3 values. If we have 3 values, what are the possibilities? What all permutation we can have? 1 3 2. I'll have 2 2. So 2 1 3 2 3 1. I'll have 3 3 3 1 2 3 2 1. What this will result me in 0. This will result in 0 1 and 1, which is nothing but 2. This will result in 1 1 and 0, which is 2. This will result me in 1 1 and 2, which is 4. 1 with this 1 2. If I subtract 2 from here, I'll get a 1 value, and 3 from here too. Fine. So 2 1 and 1. So we'll get 4 again. Now 2 0 and 2, 4 again. So it is something we got 0 2 2 4 4 4. That means we cannot make k. If k would have been 1, it would have not been possible for me to solve this. If k would have been 3, then also not possible. So that means k needs to be 0 2 and 4. This this way it is possible for me to fine. Let's take a value 4. I need to have some intuition like how the flow is going. Start with, let's have a 4. So 4, what are the possibilities? 1 1 1. So 2 3 4 3 2 sorry 2 4 and 3 3 2 and 4 3 4 and 2 4 right. So 4 3 and 2 4 2 and 3 4 2. So I have taken 1. I cannot take, sorry, cannot take, should be 4 4. And take 3 3 over here. I can take maybe 1 1 over here, and I can take 2 2 no. Okay. I can take 4 4 over here. 2 1 3. What's left? 4. What's left? 3. What's left? Similarly, same will be for 3 also. 3 1 1 2 2 4 4 3 1 maybe 2 2 and 4 4. 3 to 1 1 again, not 1 1 again, sorry. So 2 and 1, 1 and 2, right. This is for 3, last 4. So 1 1 3 2 2 1 3 2 3 1 3. Okay, so these all are possible if n is 4. So there are lots of possibilities. If in this case, let's make it 0, 1 2 will be 0. This 3 and 4 will give me what? I'm changing, if I'm changing the last 2 digits was in a sequence 1 2 3 4. If I'm changing the last 2 digits, will the value will increase by 2. It's 3 minus 4 and 4 minus 8, so value will increase, value increased by 2. Just give me a second, I'll be back in a minute. Okay, I'm back, sorry. Okay, what we were doing, we were trying to find out some intuition over here. I just wanted to know, can we get some odd values? So now if I'm changing these two values, because obviously every time at least 2 value will be swapped. If one is changing, then other will always gonna change. So uh, I'm not sure if I'll be able to get any odd values. Maybe we will be able to get something. So 2 minus 1 give me 1. 3 minus 2 will give me 1. So this will be 2. 1 3 4 2. 1 3 4 2. So 1 3 1 2 3 3. And this will also give me 1. So 1 1 2, and 4 minus 2, that is 2. So we'll get 4. 2 minus 2, that is 2 over here. 3 minus 3, that is 0. 4 minus 2, we again got 4. 2 1 and 1, we again got 4. Every time I can see we are getting any even values, not odd values. So this will give me 1. This will give me 1, that is 2. This will be 1, so it's 2 again. So this will always give me 1. Now I need to do this. No, this should did some mistake. It should not be 3 4. It should be 4 3. So 1 1 1 2. 1 from here, 1 from here, 4. 1 2. Oh, we got 3, but it's again what I did. And one 3 3 1 4 1 1 4. So 1, I got 2, total 3. This will give me a 0. No, 1 2 3 3. That'll give me 2 4 5. I got a 5 also. Right now I'm not wrong. If I'm not wrong, 1 2 minus 2, that 4 minus 2, that is 2. 3 minus 1 will give me 2. So 2 plus 1, that is 3, plus 2. 5 plus 8. I don't even know how to calculate, and I forgot the additions sign. So 2, we'll get 1 over here. Down 2 minus 4. 2 minus 4, that is 2. 1 plus 2. 3 minus 3 will give me 0. And 4 minus 1 will give me 3. 3 4 5 1 6. Again it's 6. For this y it's 5. 1 2 3 4. So 2 minus 4 minus 2, that is 2, plus 1 1 2. We are getting 2. We are getting 1 2 2 4 1 5 1 6. 6 only. So it's 6 again. Now 2 3 4. So 1 1 1 1. 3 minus 4, that is 1. 4 minus 1, that is 3. 3 4 5 6. 6 again. 1 2 minus 3 1, 3 minus 1 that is 2, 4 minus 4 that is 0, 2 3 4, you got 4 again. See, 2 4 2 0 2 4, that is what we got till now. 4 6 0 2 4 6, it's all even. This should have been solved it faster. This will give me 2, 2 minus 1 will give me 1, 3 minus 2 will give me 1, 4 minus 2 3 4, it's 4 again, 3 minus 1 2, 2 minus 1 1, 3 minus 4 1, 4 minus 2 that is 2, 4 5 6 7 6. I think 6 is the maximum. If I reverse it, if this is giving me 6, then I suppose 6 is the maximum. So 1 minus 4 that is 3, 2 minus 3 that is 1, 3 minus 2 that is 1, and 4 minus 1 that is 3. 3 4 5 6 7 8, we are getting 8 as the maximum. I suppose there should not be any value which is odd. No, so if k is odd, will directly return not possible. Now if k is even, now if it is even, I need to find answer. So if k is even, there should be a condition also that it should be lesser than some specific value.